Welcome to Rges Algebra 2, Lesson 21A. We're talking, this is section 6.4, and we're talking about how to solve systems of equations where we have two equations, and we want to find out the solution to both that would satisfy both of them. And we're going to do it by the second technique called substitution. Now, the first technique you learned was called, you could talk about it by addition or elimination by addition or subtraction. Sometimes people say you solve by elimination, and others say you solve by linear combination. Recall what that looked like was if we had a 2x minus 3y equals 17 and negative 5x plus 3y equals 13, and we get in a situation where both where one variable, if you add or subtract it, it will drop out. In this case, our y's will drop out. And so we're solving these simultaneously by adding. 2x minus 5x is negative 3x. Negative 3y plus 3y is 0y. And 17 plus 13 is 30. That's funny because I just made that up and it came out so nice and even, I wasn't even thinking. Okay, divide by negative 3. Positive divided by a negative is negative. 30 divided by 3 is 10. So we've solved for our x, then we go back and we plug into either one to solve for our y. Now that's what we did last time. What we want to do this time is to solve by substitution. Now that means, let's say I have x plus y equals 8 and 2x plus 3y equals 19. I want to take one equation, one of these two, and solve for one variable. So I end up with a statement that says either x equals something, only the x on the left, or y equals something. So I'm going to take the first one because it has no numbers in front of the x or the y, and I'll go ahead and solve it for x. X equals negative y plus 8, taking the y to the other side. So now what will I do? I will not go back and plug into the first equation because I just used the equation, but notice I have an expression that x equals. So now I go into the second equation, and every time I see the x, I plug in my expression. Just like that. Plus 3y, continuing with the rest of the equation, equals 19. Simplify this. Notice I only have y variables now, so this is a simple solution for an Algebra 2 student, right? We would distribute. We would go negative 2y plus 16 plus 3y equals 19. I would combine like terms. 3 minus 2 leaves me with y. I would take my 16 to the other side. Right now I'm adding, so I'll subtract. 19 minus 16 is 3. And we're halfway there. Now we go back now to find my x. I will go back to the expression, and x equals negative 3 plus 8, or positive 5. So my answer will be 5, 3. Let's do another one. Let's say I had 3x minus y equals 14 and 2x plus 2y equals 28. I need to get an expression that says either x equals something or y equals something. The easiest one to do will be the first one for y. Why? Because it has no numerical value before the y, so it just saves me a step. So solving just for y, so I'll solve for negative y equals the opposite of adding 3x is minus 3x plus 14. and then I need a positive y. Y equals, multiplying everything by -1, or just changing the sign, we get 3x minus 14. Here's my expression to be plugged into the y in the other equation. So this would be 2x plus 2 times the expression equals 28. Distribute. Combine like terms. Move a -28 to the other side by adding. Divide. And that's my value for x. To get my value for y, go up to the expression. Y equals 3 times 7 minus 14. Or 21 minus 14, or 7. So my answer will be 7, 7. So I've done 2. Now what happens if neither one of them, let's just pick a third example here. Let me find a good one. Hang on. What if I wanted to solve by substitution and everything has a numerical value in front? I usually take the lowest one. I'll tell this one for b. So I'll get -2b equals -3a plus 1. Solving for b, I'll get positive 3/2 a minus 1/2. Taking a negative, multiplying a -1/2 to every term on the right. This is my expression. I'll now need to go back and plug it in to the other equation. 7a minus 3, 3/2 a minus 1/2 equals 9. Notice how many steps there are in these problems. That's going to be your biggest trouble, is any one of these could allow you to take a wrong turn. So you want to be very careful with your arithmetic. 7a minus 9/2 a, that's a 9, minus 3 times the 3/2, okay, equals 9. Combining like terms, that will be 14a over 2 minus 9a over 2. 14 minus 9 is 5a over 2, okay, or 5/2 a. Okay. Adding, the opposite of subtracting, to the other side. I'm converting my 9 to halves. That'd be 18/2 plus 3/2. That'd be 21/2. Multiplying by the reciprocal, 21/2 times 2/5. Looking at my signs here, this should be a plus, negative times a negative. I told you, a lot of steps, easy to go wrong. So here I don't want, let's go back here. Let me just go ahead and make this neater. So the opposite of positive, 3/2 is minus 3/2. This would be 15/2. There we go. Multiplying by the reciprocal, I'm going to get 15/2 times 2/5. My 2's cancel out. 5 goes into 15 3 times. So my A is 3. And now I need to plug that in to my expression to get B. B equals 3/2 times 3 minus 1/2. That equals 9/2 minus 1/2, which equals 8/2, or 4. So my final answer for A, which would be, always do your ordered pair in chronological order, so it'd be A and B rather than your typical X and Y. the value of A is 3, the value of B is, where to go, 4. Okay, so that's how to do it. That should get you down through 14. And I think, hang on one second, let me decide. I'm going to go on to the parts that what would we do if they had fractions? I'm going to show you several of the even ones. This is beginning with 16 in your problems. We have x over 3 equals y over 2. And the next one is x over 3 minus y over 2 equals 1. We are trying to solve by substitution, so I'm going to take the first one, and I'll solve for x by multiplying on the right side of the equation, and x equals 3 halves y. There's my expression, plugging it in. I'm going to, okay, now, I have several choices here of what to do. Well, let me just show you here. Probably the easiest, I'm trying to debate how to teach you. I think the easiest is to get rid of the fraction by multiplying every term by the common denominator. The least common denominator of 3 and 2 is 6. So if I multiply this by 6, and this by 6, and this by 6, what would I get? 3 goes into 6 2 times. 2 goes into 6 3 times. And 1 times 6 is 6. Now if I plugged in to the x, I would get 2. 3 halves y minus 3y equals 6. 2's will cancel. I'll get 3y. Okay, let me correct this up a little bit. I thought, what is going on here? And the thing that's going on is I copied the problem wrong. So let's say it said x minus 3y equals 1. So let's go back down here, and we're going to get 2y. And I like the answer better. So x equals 6. I'm sorry, y equals 6. Now we'll go back and we'll plug that in by going up to the expression. X equals 3 halves times 6. 2 goes into 6 3 times, and x equals 9. So my final answer, 9. It would be 9, 6. So, if you have just one fraction equal a fraction, that's a good method. Let me show you another example you might have that could mess it up a little bit more. I would tend to get rid of all my fractions. Least common denominator in the top would be a 6, because 3 goes into 6 evenly. Least common denominator below would be a 10. Multiplying everything by 10. 3 goes into 6 2 times. Plus 4y, the 6's cancel, equal 24. 5 goes into 10 2, x, minus 2 goes into 10 5y, equals 2 goes into 10, 5 times 3, 15. Very tempting to want to just go ahead and subtract there. But they do ask, I don't know if they really care, actually, on this section. The first section is solved by substitution. Here they just say solve. So I'm going to say go ahead and one of them needs to be all opposite signs, so this will be a negative, a positive, a negative. Add straight down, these will cancel. 4 plus 5 is 9y. And adding here, you're going to get 9, and y equals 1. Go back and plug into either one. Technically, you should go into the top, one of the top two, but I'm going to make my life easier. Go in here. 2x plus 4 equals 24. Subtract the 4. 2x equals 20, and and x divided by 2 equals 10. So my answer would be 10, 1. So that's how I would do, we'll do the odd problems, 15 to 29, and we'll wait on that last section because that's more complicated.